start recording. So find the points on the curve where the tangent is parallel to the x-axis. For the tangent to be parallel to the x-axis, and I'm going to pause time back in, so we should have a graph that looks like this. And that's what the graph, we don't know where it is, we don't really care yet, but we do know that that's what the graph's going to look like. The other thing we know is that if the tangent line is parallel to the x-axis, well, we know what parallel means, and we know where the x-axis is and what it looks like. And so we're going to have two spots on this graph in which the tangent line is parallel to the x-axis. Okay, well, how do we find the slope of a tangent line? Well, we know the slope. Okay, we know that the slope is y prime. Okay, and we know that the slope is y prime. Okay, we just have to find y prime of what? Okay, let's call this x1, and we'll call this one over here x2. So we're going to have two places along the x-axis, two real numbers that will force the slope of the tangent line to be 0. Okay, and we know again, parallel lines are parallel to the x-axis, or horizontal lines have a slope of 0. Okay, and so if we want to find the slope of the tangent line, we know that that means we're going to find the derivative. And the derivative would be equal to, the derivative of 2x cubed is 6x squared. The derivative of 3x squared is 6x, and the derivative of negative 12x is negative 12. So we easily find the derivative, and we need to know when is the derivative equal to 0. Okay, and so the derivative is equal to 0, and this is what I want you to write, how you're going to do these. When 6x squared minus 6x minus 12 is equal to 0. And we know how to solve that. We can just divide everything by 6, or we could factor out a 6 if we wanted to, but dividing by 6 simplifies everything. And we get x squared minus x minus 2 is equal to 0. And then the rest is just that algebra 1 stuff where we factor the left side and we set each factor equal to 0. So we get x, so we say therefore x is equal to 2 and x is equal to negative 1. Okay, so that gets us the two x coordinates of these points on the curve that force the tangent line to be horizontal. So we know the tangent line is horizontal, slope of the tangent line is 0, when x is equal to, what did I say? 2 and negative 1. So this guy right here, this is the negative 1, x is negative 1, and then over here, this is the x value of 2. Okay, so now we know the specific x values, and I could, if this weren't a video, I would say just go ahead and find the y values, but it is a video, so I want to go ahead and finish it up. How do we find the y value when we know the x value? Just plug it in. I mean, that's what goes back to way back to algebra 1, where you go, well, we know the x is negative 1, and then we plug in negative 1 and we get negative 2, and then minus 3, plus 12. Be careful here. I'm not showing every little step. Okay, plus 20. And what do we get? We get 32, we get 27. Did I do that right? 32 minus 2 is 30, minus 3 is 27. So we get the coordinates of one of the points are, doing a different color here, negative 1 comma 27. Okay, and then we also want to find y of 2. Did I make a mistake? Okay, good. Y of 2 would be 2 times 2 cubed. This is where I'm going to do more work. Minus 3 times 2 squared. Minus 12 times 2. And then plus 20. And I hope it's less than 27. It better be less than 27. 2 times 8 is 16. Minus 3 times 4 is 12. Minus 24 plus 20. And what can I combine here? 16 and 20 is 36 minus, nice, minus 36, and we have 0. So we have the coordinates 2, 0. Okay, and so we have our answer. Coordinates to this point are negative 127, and the coordinates to this point are 2, 0. Okay, that's it.